Earthquakes are a way of life in California, but every once in a while there's an earthquake that changes us, and the Loma Prieta earthquake was one of those. It happened on just a random Tuesday in 1989. It was 5:04 in the afternoon. It was the third game of the World Series. The Oakland A's were playing the San Francisco Giants in Candlestick Park when, just north of Santa Cruz, a magnitude 6.9 earthquake started on the San Andreas Fault. This is a computer simulation from the USGS showing seismic shaking from the Loma Prieta earthquake as it spreads out across the Bay Area. When the dust cleared, 67 people were dead, 3,700 people had been injured, and there was more than $5 billion with a B, dollars worth of property damage, including the collapse of the Nimitz Freeway in Oakland. Now, this earthquake really kind of brought home the idea that the local rock and soil conditions are going to help control where we have the strongest shaking and where we see the most damage. This video is similar to the one that I showed before, but instead of showing kind of the seismic waves, this is showing the actual shaking intensity of the ground during that earthquake, or how hard the ground shook. Every earthquake has one magnitude. That's the amount of energy that's released during the earthquake, but each earthquake can generate many different intensities of earthquake shaking. So in this image, the areas of red, orange, and yellow are areas that experience strong, severe, or even violent shaking. The areas in blue and purple are areas that experienced mild, weak, or light shaking. And you can see as the animation progresses that certain areas are continuing to shake harder and harder. And if you especially look in the areas around Oakland, the areas around the San Francisco Bay, there are particular areas that shake really, really hard compared to the areas nearby. And that's because of the local rock and soil conditions. When you have soft sands and soils, and then you send seismic waves through them, they're actually going to shake harder and for a longer period of time, almost like a bowl full of Jell-O. One year after that earthquake, and as a direct result of the damage that was done from that earthquake, the state of California enacted legislation that directed the California Geological Survey to identify and map seismic hazards like liquefaction, or where the ground kind of turns to quicksand during seismic shaking, earthquake-induced landslides, places where you have steep hills and weak rocks, and then you combine that with strong shaking, you can get landslides, and also areas of ground amplification. So they passed the Seismic Hazards Mapping Act, right? And so now the California Geological Survey makes maps to help people make wise land use choices in order to reduce seismic hazard and risk. If you would like to visit some of those, see, if you live in California, what hazards there are around you, you can go to the California Geological Survey website. You can go to our EQs app. It's an interface that looks like this. You click on that and you can get all the information that you need. We can't stop the earthquakes in California, but we can make sure that we can mitigate the hazard and risk so that we don't just survive the earthquake, but thrive in the aftermath.